Hello everyone, welcome to the Mutual Fund Analyze Part 2. In Part 1, we talk about obtain data from internet and visualize data with multiple funds. Now we are going to do some data analysis work in Excel. In this video, we are going to focus on portfolio optimization. Because the data are stored in different workbooks, first we need to centralize the data by running this program. This time, we are collecting the monthly percentage change of the fund. So all the expected return and the standard deviation are based on monthly. Okay, so we have all the data in this workbook now. We can start working. We are going to start from two fund portfolio, then move to the multiple fund combination. But before we do that, we need to find the beta figure of each fund. I am using SP500 as the index. Here is the result. We sorting in ascending order. No surprise, we see on the top, most of them are fixed income fund. Some of them are negative correlated with SP500. What's interesting is we see two low volatility funds here. It will be a good start to choose two funds negative correlated. Okay, the first two columns are the monthly data of the fund. Here I can change the fund combination. All the data will update automatically. I have set the time period at 120 months, so it will cover the 2008 crash. If we change it to 80 months, we can see the standard deviation will drop down significantly. I'm using Excel function average and standard dev to calculate the expected return and the standard deviation. Then there are two metrics, correlation matrix and the variance-covariance matrix. They are used to calculate the portfolio expected return and the standard deviation. Here we use Excel function correl to calculate the correlation coefficient. And in the variance-covariance matrix, we are using HLOOKUP to help locate the standard deviation of each fund, and use Excel autofill function to help fill all the cells with the correct function. Here we only have 2x2 matrix. Seems a little bit overkill. But if we have 10x10 matrix, we'll save a lot of time. Here is the formula of the portfolio expected return and the variance. We use function SUMPRODUCT to get the portfolio return, and use Excel's array function and mult and transpose to do the matrix multiplication between weight and the variance-covariance matrix to get the portfolio variance. With all the cell linked by Excel function, we can change the weight here. The portfolio expected return and the standard deviation will automatically update. Then we have two utility formula with different approach dedicated to find the optimized weight for each fund. Here are the two formula. We know we want the portfolio's expected return to be as large as possible and the standard deviation to be as small as possible. So there are two approaches. One is using subtraction, another using division. The first one I think is coming from macroeconomics field. We see both formula has the parameter A and B. I used to adjust the risk tolerance of investor. If the parameter B is set to 1, the second utility formula is just a Sharpe ratio. So we can find the highest return per risk unit. We can see on the chart on the x-axis is the portfolio standard deviation. The blue dot are the portfolio expected return on each risk. And the red dot are the utility on each risk. So if we decrease the parameter A and B, on the chart, we can see the largest utility point will both shift to the right, which means the investor willing to take a higher risk for higher return. With everything be set, we can run the first program, which is just looping the first fund's weight from 0% to 100%. Put it into the blue cell here to find the optimized portfolio weight for maximize utility 1 and the utility 2. And in the meantime, find the minimized standard deviation too. Then we put the results into this region. I call this program single optimization. Let's choose Fidelity 261 for example. And here is the results. We see the results of the utility 2 and minimize the standard deviation. They both have a smaller standard deviation than any of the found. Now we can go one step further. Let's say we want to find the optimized results between MMF559 and every single found available in the database. Here is the program. I call it a loop second found. It leaves the first found Manulife 559 untouched. The second found will loop through all the found available in the database. And in every loop circle, you will run the program's single optimization to get the optimized results and put them in a table. So here is the results with the parameter A set at 12. We can sort them. The largest utility one is 0.59 with the found MAWA107. We see the top combination do have relatively higher return and lower standard deviation compared to the one on the bottom of the list. We can sort utility 2 and minimize the standard deviation too. And we can change the parameter setting to get the results with different target return and the risk. We see here I have two programs to loop the second found. They did the same job. The only difference is I changed the algorithm of the program called single optimization. Here's the idea of the original design, which is simply set a start point 0 and end point 100 with 1% each step and find the optimized value. So the program will loop 100 times and with accuracy 1%. The revised program also have a start point 0 and the end point 100. But divided the range by 10. So in this case is 10% each step and find the optimized value. We know the more accuracy value should be resided in the range of one step back and one step forward. So the program will recall itself to set the new start and end looping point to be the range's start and end point. And then divide the range by 10 and find the optimized value again. We can set how many times the program recall itself to reach the accuracy we want. In this case, if the program recall 2 times, it will loop total 30 times with accuracy 0.4%. By using this method, the division setting by 10, which is not the most efficient one, here is a table of division setting from 2 to 10, with the detail of looping circle required for certain accuracy. If we view the data in a scatter chart, we can see at almost any accuracy level point, division setting at 5 and 6 required the least looping circle. So theoretically, it will run almost 5 times faster than the original one. With the efficiency being improved, then we can go one more step further to loop through all the possible two-found combination to find the maximum utility value and the minimum standard deviation with the parameter setting we choose. Here is the result. Then we can sort them to see in this found pool. The lowest portfolio standard deviation between two found combination is 0.79 between found Manulife 4529 and the TDB 306 with the weight setting 36 and 64. And we can see the utility 1 results. TDB 330 become the best choice for most of the found to generate the largest utility value. And for the utility 2, PHN110 become the popular chosen one. Again, this result is based on the current parameter setting and the 120 months period setting. So any found available in the database with the historical data less than 120 months will be excluded in this optimization test. Okay, that's concluded this video. My next video, in part 3, we will talk about using Huang and Lisenberger's method to find the efficient frontier, so we can find the optimized weight of a portfolio with multiple funds. Thanks for watching. I will see you soon.